Hello students, today we are doing current electricity question series again. So we'll be going through a couple of questions, actually finding equivalent resistance, finding current through capacity, finding current through resistors and cells as well. So I'm giving you actually question models. Remember that these questions are common. So I mean common models actually. So if you cannot do one type of questions, that means there are yes, there's a high chance you won't be able to do questions from current electricity. So it's always if you should be able to do every question model. So if you do not know how to do the question, that means you don't know theories or you haven't practiced. So make sure you practice questions quite a lot. So let's start with this question now. Right, students? This question, they're asking us to find the equivalent resistance and current through the cell. So basically here we have only one cell, so we won't have that much of a problem. If there are more cells, actually we need to add the cells, and we might need to apply Kirchhoff's laws as well. Right. So here we don't need to apply that. We just need to find the equivalent resistance. If you can find the equivalent resistance by applying the parallel and series methods, you are good to go. So the first thing I'm gonna do, we have to add the resistors that are parallel. 6, 4, they are parallel. So you can easily add them. Let's add 6 and 4. So these two are parallel. So you know the equation 1 over R plus 1 over R1. That's the equation. So 1 over R equals 1 over 6 plus 1 over 4. Then we take the common denominator, that's 24. Here we get plus and 6. Then we take the reciprocal value. So 24 over 10, that's 2.4 ohms. That is our answer once we add 6 and 4. Right. Then I hope you can see the current flow from 7.6 that goes to the other two resistors. That means 7.6 and this 2.4, they are in series. So we can directly add 7.6 plus 2.4, that's 10. That means we have a 10 ohms resistor. Let's draw it like this. We have 10 ohms resistor up to here, 10 ohms. Then it's easy. It's connected actually from this wire. I hope you can see it. So we can take it. There's no current flow because it's connected by a wire. So potentials are same. So you can. Here, I'm gonna take these two are parallel and these two are parallel. So 1 over 20, because these two are connected here, that means 20 and 30 are parallel and 40, 10 are parallel. So 1 over 20 plus 1 over 30. Common denominator is 60. 3, 2. So let's take the reciprocal value, 60 divided by 5. That's 12 ohms. In between we have 12 ohms. And then let's simplify this one. 1 over 40 plus 1 over 10. 1 over 40 plus 1 over 10. Common denominator, that's 40. 1 plus 4. So that's 4 over 5. That's 8. So we have 8 over here. We have 8 ohms. This 12 ohms plus 8 ohms, altogether we get 20 ohms. That's the total resistance, equivalent resistance 20 ohms. So the current will be total resistance 100 divided by 20, that's 5 amperes. Those are the answers we get for this question. Moving into our second question. This question actually we can do by using the potential divider method, by using the ratio method. We did a video on ratio method. I hope you have gone through it and you are thorough with ratio methods, right? So let's try this question now. They're asking us to find the potential difference A, B here. So we have to start from there. You know, we have for the entire system we have 400 volt battery, and that goes along the circuit. And from here it's divided into 2R and 2R. For here it's 200, here 200. Yeah, we can take it like that, but it's not. This 200 potential, this 200 resistance is not only here, because it's, yeah, we have all the other circuits here. Current goes in this direction, this way, this way, this way. So not basically 2R here along with this 2R. This 2R is actually there, that's you can see, but this 2R is not just there. It is connected with other resistors. So you cannot take it as 1:1 and this 200 and 200. No, you cannot do that. What we are trying to do is we are trying to find the full equivalent resistance over here. Right. So we have to add from the free end. This is the free end. 2R and 2R, that's not connected to any other thing. Only we have 2R and 2R. If we consider other 2R and 4, it's not connected. 2R and 4R, no, it's not connected. So free connecting resistors are only 2R and 2R. I hope you understand what I'm saying by this free thing. Right. 2R, 2R, you can easily add them. 2R, 1 over 2R plus 1 over 2R. Common denominator is 2R, so 1 plus 1, let's take the reciprocal, it's R. Right? So I hope you know, if you add in parallel way, similar, same value of resistors, we can divide it by the number of resistors. So if for example, if we have our number of resistors parallel, the equivalent will be R divided by N. You should know these things. So it's R. Then we get R here. R and R, it becomes 2R, and 2R is what we have to do, we have to divide by 2. That becomes R. And this R and 3R, that becomes 4R. 4R, that becomes, yeah, 2R. 2R, that's 4R, right? 1 over 4R plus 1 over 2R. Common denominator 4R. So we have 1 here, we have 2 here, then the equivalent will be 4R over 3. We have 4R over 3 resistance here. Now let's take the ratios. 400, right? That's the ratio now we have to take. 2R raised to 4R over 3. So we cannot keep the fraction like this here. So we have to multiply it by LCM. So LCM will be 3. So we multiply it by 6. 6R is to 4R, 6 is to 4. Now we can simplify if you want, which 3 is to 2. That's the ratio. That's the resistance ratio. Of course, we know resistance ratio is equal to the potential ratio. Right. Let's take the fraction now. It's 3 plus 2, 5. So it's 3 over 2 and 2 over 5. So they're asking us to find AB here, AB. So we need to find the potential gap here. It's 2 over 5. So 400 into 2 over 5. So we are getting 80. It's 80, right? Yeah, 80. 160 volt. So here we get 160 volt. Now it's easy. 160 volt in between. Again, 2R and 2R. 160 volt in between. 1:1 ratio. We have, yes, 80 volt across this. Right. Then again 3R and R. Remember that. Now it's tricky. 3R and R. Right. 3R and R. That means 3:1 ratio. We have to divide this 80 thing. So again ratio 3 over 4 and 1 over 4. That multiplied by 80 we get 20 volt. So across this R we have 20 volt. 2R and 2R, of course, we have 20. R and R, right? 20, 10 and 10. 1:1 ratio, 10 and 10. I hope you can get it. 10 and 10. So across this we have 10 volt. Again, AB and these two are parallel, so it's 10. That is our answer. Students, if you have practice questions like this, it's easy to get the answer. Yes, this type of question may come around 30 to 35 questions, but if you have practice, it's easy. You can easily do the question, and accuracy is high and it's fast. Right, let's move to the other question now. Students, moving into the third question. Actually, it's similar to the second question, right? I thought of doing actually this type of questions because you might find it difficult to do questions like this. Basically, when you are doing actually questions from current electricity, you need to check the direction of current as well. To do this question, I'm doing two things. One thing I'm doing is that I'm going to ground here. So when I make it ground, so its potential here is 0. Right? That I have the facility, and yeah, okay. And then, yeah, let's draw the direction of current. Current will start from here, it moves here, it moves here, and it moves here. And then it will go in this direction, it will go in this direction, it will go in this direction, certain amount will go in this direction, this way, this way, this way, this way, this way. Current will not flow in this direction because we have this voltmeter here, because we assume the internal resistance of potentiometer is infinite. There's no current through it. So what I am doing again in the very same method, I need to find the potential here, this point. If I have the potential at that point, because I have the potential at this point, so that difference is a voltmeter reading. Right. The free end is this. These 10 ohms, these 10 ohms I can easily add. Others have commitment, actually they are connected everywhere. Right. So 10 plus 10, so you learn this trick from the previous question. Similar questions, 2 branches, 10 divided by 2, that's 5. 5, I'm going to write it here, 5 and this 5, yeah, 5 and 5, 10, right. So up to here, this point, these 2 points, we have 10, right. So this 10 and this 10, these 2 are parallel, 10 and 10 again, 5, 5. Right. Up to here we have 5. I'll draw it like this. Now this 5 ohms, and then we have 5 ohms. Now we can divide the potential. So for this 10 ohms potential, we have 5 ohms, 5 ohms, 10 ohms. Let's write it down. We have 5 ohms, 5 ohms, and 10 ohms. Right? So we need only to find the potential gap between this 5, right? I'm going to apply that. There are plenty of methods. I can find the current and divide it, but I'm still going with the potential divider method, ratio method. So I'm taking the ratio 1:1:2. So 1/4, 1/4, 2/4. So 1/4 into 10. And I'm getting 2.5 volts. So potential difference across these 2.6. 2.5 volt. Again across this point it's 2.5 volt. Rest it should be 5 volt here. So the potential here, now let's think of it. Potential here 0. Potential difference, yeah, that's 5, right? So here this point it has to be 5 volt. Again this 0.5 volt, this 0.5 volt. Alright. Then the potential difference here, we have found it as 2.5, then the potential difference 2.5, so the point here, this potential it has to be 7.5. That means here the potential is again 7.5 volt. 7.5 and 5. Potential difference again it's still 2.5, right? Okay, we are getting closer to answer now. In between 10 and 10, once these 2 added, it's 5, right? 5, 5, 5, 5. In between we have 2.5 potential. So 2.5 divided by 2, it's 1.25 across this point. 1.25 across this point. So 5, difference is 1.25. It has to be 6.25, right? 6.25. So here 0, potential here is 6.25. The voltmeter reading will be 6.25 volt. Yeah, my method will be maybe a bit complex. It's a very simple method actually. If you haven't practiced voltage divider method questions like this, then you might feel it a bit confusing, but still try to go through it. If you can master these techniques, you can easily do current electricity questions.